This is the user interface for the image analysis machine learning model. We will demonstrate its functionalities with the vesicle task. The user can start with uploading the image of interest and its associated machine learning predictions. The software will display the machine learning prediction results in the right table, and on the left figure is the predicted masks overlaid with the original image. The user can tune the opacity of these masks to better see the prediction quality. In this image, there are three main microstructure features of interest: the transparent large bubbles, which are large biological vesicles, the small black circles, which are small vesicles, and the white small circles, which are holes left by the small vesicles. In the phase 1 project, we succeeded in predicting the large and small vesicles, which can be seen from this mask. And we can also tune the color scheme of these masks. For example, we can change it to Arial, which is the number of pixels within each object. Then the score option is also interesting. It is the confidence score returned by the machine learning model for each object. A high score indicates that the machine learning model is pretty sure about this prediction, and a low score indicates that the model is unsure. Here we have an object associated with a relatively low score, less than 0.1. So it's probably a mistake, and let's delete it from the table. It will also be deleted from this figure here, and we see the color bar also updates. Our second lowest score is about 0.9, which is pretty decent. Just to make sure, let's zoom in and have a look at this low confidence score object. We see that it's actually probably a valid large vesicle. So let's keep it, zoom out, turn the opacity back on, and change the color option to classes. So we just corrected the false positives. Now here are some false negative predictions, meaning that they are true microstructural features, small vesicles, but the model didn't detect them. Let's fix this problem by just drawing them with our hand. As we draw, their data will be added into the microstructure data table on the right, just as the machine learning model predictions. Now we have a pretty decent mask for microstructural objects in this image. We can click on the objects and their data will be highlighted. We can also compute microstructural statistics using this good object mask. For example, in this vesicle task, we are interested in the size distribution of the vesicles. We can select it, and it will be automatically computed from our mask. We see a bimodal distribution here, which is not surprising. This first peak is probably associated with the small vesicles, and the second peak is contributed by the large vesicles. We can also see some other distributions like the perimeter distribution, and these are the two main important microstructural statistics for this vesicle task.